Hello students, welcome to LUCID Study. This is Satya. So today in our class we are going to discuss the topic whole numbers of Class-6 Chapter-2 of AP&TS Syllabus. So children, why are numbers very important for us? So numbers are very important to count things, right? So if there are no numbers, how it would be? It would be very difficult for us to count anything. So we use number in various types of in our lives. So now we will use these numbers to count this. So children, here you can see there is a banana, apple, banana, apple. So now let us count the total number of apples here. So as you can see children, 1, 2, 3, 4, 5. So total number of apples are 5. So now let us count mangoes. 1, 2, 3. So now let us count oranges. 1, 2, 3, 4, 5. And bananas. 1, 2, 3, 4, 5. So counting numbers are also called as natural numbers. So numbers are very important to count things. So these natural numbers are represented with capital N. They are also said to be counting numbers. So children, did you ever think that what are whole numbers and where do they start from? So now in our topic today we are going to discuss about whole numbers. So children, before going to whole numbers, let us know few topics about predecessor and successor. So what is called as a predecessor? Predecessor is a number just comes before any other number. So here I am taking 5. So the number which comes before 5 is 4. So 4 is called the predecessor of 5. So the number which comes just before other number is said to be a predecessor. Then what is successor? So there is a number 3. So what is a number that comes just after 3? That is 4. So here 4 is called as a successor. So now let us do some examples. So successor of 6 is nothing but the number just comes after. So successor of 6 is 7 and predecessor of 6 is nothing but the number which is just before 6, that is 5. So predecessor of 6 is 5. Now let us go through whole numbers. So children, what are whole numbers? So children, did you ever think that what is a predecessor of 1? So the predecessor of 1 is 0. So as you know children, the natural numbers start with 1 and end up to infinity. So when we add 0 to the collection of natural numbers, we get a collection called whole numbers. So whole numbers start from 0 and end up to infinity. So now let us know more about whole numbers. So the smallest whole number is 0. The largest single digit whole number is 9. And whole numbers are represented with capital W. They start from 0, 1, 2, 3, 4 and so on. So now let us learn how to represent these whole numbers on a number line. So children, this is how we represent whole numbers on the number line. So as I told you students, whole numbers start with 0. So the number line should also start with 0. Starting with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. Whole numbers should always start with 0 and they do not have any endpoint, because that is why we call that whole numbers end up to infinity. Now let us go through some examples. So children, now let us learn how do we add the numbers on the number line. So here it is 3 plus 4. Children, always remember that when we add whole numbers, we move on the right side of the number line. So children, here as you can see, 3 plus 4. What is 3 plus 4? 3 plus 4 is nothing but 7. Now we will learn that how to represent this addition on the number line. So starting with 0, draw the number line and label them with numbers. So as you can see here, 3 plus 4. So 3 is here and 4 is here. So when we add 3 to 4, that is nothing but 1, 2, 3, 4. What do we get, children? We get 7. So this is how we represent additions on the number line. Now let us learn how to represent subtractions on the number line. So now children, we will learn how to represent subtractions on the number line. So children, as you can see here, here is a number 6 minus 4. So children, what is 6 minus 4? 6 minus 4 is 2. Now, when you represent the subtractions on the number line, you need to move on the left side of the number line. So from 6 move 4, 1, 2, 3, 4. So what is the answer? 2. So 6 minus 4 is equals to 2. So as we are subtracting it, we are moving on the left side of the number line. So now children, we will learn about multiplications on a number line. Children, you know how to multiply numbers, right? Now we will learn how to represent these multiplications on the number line. So here as you can see, 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10. So this is nothing but children 2 into 5. So what is 2 into 5 children? 2 into 5 is 10. So children, here as they are whole numbers, we are moving on the right side of the number line when we multiply. So 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10. So that is nothing but 2 into 5 is equals to 10. So children, this is how we represent the multiplications on the number line. Let us go through exercise 2.1. So here is the first question. Which statements are true or false? The first question is, there is a natural number that has no predecessor? Yes. Is that true? No. 1 is a natural number but it is having a predecessor and that is 0. So that means this statement is false. 0 is the smallest whole number. Yes, this is true. Whole numbers are natural numbers. So children, all whole numbers are natural numbers? No. All whole numbers are not natural numbers, right? 0 is a whole number but it is not a natural number. So that means this statement is false. A whole number that lies on the number line lies to the right side of another number is the greater number. Children, yes. So when we draw the number line, we know that the greater number lies on the right side of the another number. So that means this statement is true. A whole number on the left of another number on the number line is greater. Now children, if any number is on the left side of the number line, that means the number which is on the left side is the smaller number. Here this statement is false. We can't show the smallest whole number on the number line. We can show the smallest whole number, right? 0. 0 can be shown on the number line. So that means here this statement is false. We can show the greatest whole number on the number line. Is that possible, children? No. So that means this statement is false. So children, now let us go through the next one. So children, now this is the second question. How many whole numbers are there between 27 and 46? So children, whole numbers are nothing but natural numbers except 0. So now let us write the whole numbers between 27 to 46. So 28, 29, 30, 31, 32, 33, 34, 45 and 46. So children, now count the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So is that right, children? Yes, there are 18 numbers. So now let us go through the third question. So find the sum using number line. So here is the first question. 6 plus 7 plus 7. What is 6 plus 7 plus 7? 7 plus 7 is equals to 14. So 14 plus 6 is equals to 20. Now we will show this on the number line. From 0 to 6, 6 added to 7 is 13 and 13 to 20. So this is how we represent the additions on the number line. 0 to 6, 6 to 13 and 13 to 20. Now next one, 18 minus 9. What is 18 minus 9? 9 plus 9 is equals to 18. So 18 minus 9 is equals to 9. So from 18, 1, 2, 3, 4, 5, 6, 7, 8, 9. Children, we are moving on the left side of the number line because we are subtracting a number. So 18 minus 9 is equals to 9. Now let us go through the third problem. So here is a third problem, that is 5 into 3. Children, as I told you, when we multiply whole numbers, we move on the right side. So 0 to 5, 5 to 10 and 10 to 15. So that is nothing but 5 into 3 is 5 into 3 is equals to 15. Is this right, children? Yes. This is how we represent the additions, subtractions and multiplications on the number line. Children, always remember that when we add and multiply a whole numbers, we move on the right side of the number line. But when we subtract a number, that is a whole number, we move on the left side of the number line. So now let us learn more about whole numbers. So children, here is a fourth question. In each page, state which whole number is on the number line is on the right side of the other number. So children, the number which is on the right side of other number is nothing but that it is a predecessor or successor. It is the successor because the number which stays on the right side is always its successor. So the successor of 895 is 896. So the successor of 239 is 240. The successor of 1001 is 1002. The successor of 10,001 is 10,002. The successor of 1 crore 15,678 is 1 crore 15,679. So the successor of 2,84,013 is 2,84,014. So children, this is how we write the successor of the numbers. Successor is nothing but the number which comes just after the number. So successor of 6 is 7 and predecessor of 6 is 5. Now let us go through the next problem. So children, here is the fifth question. Mark the smallest number on the number line. So children, as I told you before, the smallest whole number is 0. So here the smallest whole number is 0. The smallest whole number is 0 and the smallest natural number is 1. So as the question is here whole number, so that is why we need to mark 0. If it is a natural number, then we need to mark 1. So children, here is the sixth question. Choose the appropriate symbol, greater than, less than or equal to. So children, is 8 greater than or less than 7? 8 is greater than 7 because 8 lies on the right side of 7. So here 8 is the greater number. 5, 2. As you know children, 5 is a greater number than 2. 0 and 1. 1 is a greater number than 0. 10, 5. 10 is a greater number than 5. Children, always remember that 2-digit numbers are always greater than 1-digit number. That is why 10 is greater than 5. Now let us go through the next problem. Children, now let us learn the properties of whole numbers. So, what are properties? So, properties help to simplify problems very easily. So now let us learn about some properties. So children, before going to properties, let us know that what are the properties we are going to learn. So in the properties of whole numbers, we are going to learn about closure property, commutative property, associative property, additive identity. So what is 2 plus 3 children? 2 plus 3 is equals to 5. 0 plus 7, 0 plus 7 is equals to 7. 20 plus 15. What is 20 plus 15? 20 plus 15 is equals to 35. 0 plus 0, 0 plus 0 is equals to 0. So children, as you can see here, when two whole numbers are added, the sum is also a whole number. So this property is called as closure property. In closure property, if there are two numbers a comma b, when a plus b is added, the result should be a whole number. So 2 plus 3 is a whole number. So when 2 plus 3 are added, we get the sum 5. Sum is also a whole number. So that is nothing but whole numbers follow closure property. Now let us go through the next property. Children, we learned closure property of whole numbers under addition. Now let us go through closure property of whole numbers under multiplication. So children, here are two whole numbers 5 and 6. So when 5 and 6 are multiplied, what is the product? 5 into 6 is equals to 30. So here are what two more whole numbers? They are 11 and 0. So 11 into 0 is 0. Children, always remember that any number multiplied with 0, the product is 0. So that is why 11 into 0 is equals to 0. One more example is 5 into 0 is also 0. So 15 5s are. So what is 15 into 5? 15 into 5 is 75. So children, here the product of two whole numbers is also whole number, right? Yes, 5 into 6. So here 5 and 6 are whole numbers. The product we get is also a whole number. So whole numbers also follow closure property under multiplication. Whole numbers follow closure property under addition and under multiplication too. Now let us learn another property. Children, we divide numbers every day, right? Now let us learn how to divide by 0 or how to divide 0. So what is 6 divided by 2? 6 divided by 2 is nothing but 3, because 2 into 3 is 6. So then what is 3 divided by 0? Children, 0 cannot divide any number. So if 0 divides any number, the result is, that is the quotient is meaningless. So that is why we write it as undefined, right? So 3 divided by 0 is undefined. Children, but 0 is divisible by other numbers. So 0 into 3 is nothing but 0, because 3 into 0 is 0. That is why 0 divided by 3 is equals to 0. Any number can divide 0, but 0 cannot divide any number. Now let us go through another property. Children, what is commutativity? Now let us learn what is commutativity of whole numbers. So commutativity is nothing but when we change the order of the numbers, the sum should be same or the product should be same. So here, what is 2 plus 3? 2 plus 3 is equals to 5. So now let us change the order and we'll check it that when the order is changed, is the sum same? Yes, 3 plus 2 is also 5. 2 plus 3 is 5 and 3 plus 2 is also 5. So whole numbers follow commutativity under addition. So children, if there are two integers a comma b, a plus b is equals to b plus a. Here a is 2 and b is 3. So a plus b is equals to b plus a. Now let us solve some more examples. So let us take few more examples. As A is equals to 7, B is equals to 3. So as I told you, A plus B is equals to B plus A. So what is A plus B? A plus B is nothing but 7 plus 3 and B plus A is equals to 3 plus 7. So 7 plus 3 is equals to 10 and 3 plus 7 is also 10. So that is nothing but A plus B is equals to B plus A. So whole numbers follow commutativity under addition. Now let us check it in multiplication. So now let us check it for multiplication. So I am taking two whole numbers 4 and 3. So now let us check that is A into B is equals to B into A. So children, here A is 4 and B is 3. So A into B is nothing but 4 into 3 and B into A is nothing but 3 into 4. So what is 4 into 3? 4 into 3 is 12 and 3 into 4 is also 12. So children, this is called as LHS and this is called as RHS. So LHS is equals to RHS. So here we can learn that A comma B whole numbers follow the commutativity under multiplication. So here A into B is equals to B into A. Now let us learn about associativity. So children, what is associativity? So associative property is nothing but first we need to group two whole numbers together. So we can group this in two ways. First we can write it as 3 plus 4 as a group and add 5. This can also be written as 3 plus 4 plus 5. Now let us check that is the sum same. So what is 3 plus 4? 3 plus 4 is 7 and 7 plus 5. 3 plus, what is 4 plus 5? 4 plus 5 is equals to 9. Children, we got 7 plus 5 is equals to 3 plus 9. What is 7 plus 5? 7 plus 5 is equals to 12. What is 3 plus 9? 3 plus 9 is also 12. So children, LHS is equals to RHS. So that is nothing but whole numbers follow associativity. So LHS is equals to RHS. LHS is nothing but left-handed side and RHS is nothing but right-handed side. So LHS is 12 and RHS is 12. So the whole numbers follow associative property under addition. Now let us check it for multiplication. Here 4 into 3 into 2. Now let us group into two ways. So 4 into 3 into 2 is equals to 4 into and 3 into 2 as a group. What is 4 into 3 into 2? 4 into 3 is 12. 12 into 2. So 4 into, what is 3 into 2? 3 into 2 is 6. 12 into 2 is 24 and 4 into 6 is also 24. So children, LHS is equals to RHS. So this is called associative property of multiplication of whole numbers. So whole numbers follow associative property. So A into B into C is equals to A into B into C. Now let us go through another property. So children, now we will learn about additive identity. Additive identity is nothing but when we add 0 to a whole number, we get the same whole number. So for example, 6 plus 0. What is 6 plus 0? 6 plus 0 is 6. 0 plus 4. 0 plus 4 is equals to 4. So children, when any number is added to 0 or if 0 is added to any other number, the sum is the same number. The value does not differ. So 0 is called as the additive identity. Now we will learn about multiplicative identity. Multiplicative identity is nothing but 1. So if any number is multiplied with 1, the product is the same number. So for example, 1 into 9. So when 1 is multiplied with 9, the product is 9. 6 into 1. So when 6 is multiplied by 1, the product is 6. 14 into 1. 14 into 1 is 14. So 1 is called as a multiplicative identity. If any number is multiplied by 1 or if 1 multiplies any number, the product is the same number. The value does not differ. So that is why 1 is called as a multiplicative identity. Now let us learn another property. Now we will learn about distributive property. What is distributive property? So when two numbers are multiplied, that is nothing but we need to distribute the numbers into two halves. So 5 into 4 is nothing but 20. So 1, 2, 3, 4, 5 and 1, 2, 3, 4. So children, this can also be written as 1, 2, 3, 4 and 1, 2. This also be written as 2 into 4 plus 3 into 4. So now let us solve it. So 5 into 4 is 20. That is nothing but 2 into 4 plus 3 into 4. 2 into 4 is 8 and 3 into 4 is 12. So what is 8 plus 12? 8 plus 12 is equals to 20. So children, is the product same? Yes, the product is same even when we separated the parts into 2. So 5 into 4 is written as 2 into 4 plus 3 into 4. Now let us go through the exercise. So this is exercise 2.2 and here is the first question. So give the results without actually performing the operations using the given information. Children, we learnt all the properties, right? Yes. Now we will use these properties and solve these problems. So here is our first one. 28 into 19 is equals to 532. Then 19 into 28 is, so children, if you observe here this is A and this is B. So when A is multiplied with B, the answer is same when B is multiplied with A. So here 19 into 28 is also 532. Here is the next one. 1 into 47 is equals to 47. Then 47 into 1 is also 47. This is multiplicative identity. Did you remember, children, that if any number is multiplied by 1 or if any number multiplies 1, the product is the same number, right? Yes. Now we'll go through the next one. A into B is equals to C. Then B into A is also equals to C. So this is commutative property under multiplication, right? A into B is equals to B into A. Yes. Now let's go through the next one. 58 plus 42 is equals to 100. Then 42 plus 58 is also equals to 100. Children, this property we have learnt in commutative property under addition. A plus B is equals to B plus A. Now 85 plus 0 is equals to 85. Then 0 plus 85 is also 85. This is called as additive identity. When 0 is added to any number or if any number is added to 0, the sum is the same number. Now let us go through the next one. A plus B is equals to D. Then B plus A is also equal to D.